Hello students, in our previous topics, that is in electric charges and fields, electric potential and capacitance. So in that situation, we have discussed the charges are in the rest, means that is the electrostatics. Charges are in the rest. Right now, here we are discussing about the current electricity, means charges are in the motion. Charges are in the motion. So right now we are discussing about the current electricity. Current electricity. So in this topic we are discussing about the when charges are in the motion, but in this electrostatics, charges are in the rest. In that situation we discuss about the what is the force, electrostatic force. So what is the electrostatic force of attraction or maybe repulsion in between the charges? What is the electric field intensity due to the point charge? What is the electric potential energy between the two charges? So these are we discussed in the electrostatics. But here, in case of the current electricity, charges are in the motion. When charges are in the motion, try to observe first of all. Water or maybe liquids are flowing from the height to the down. So in case height to down, height to down. So in case of the gases, try to observe in case of the gases. Gases are flows from the high pressure region to the low pressure region. High pressure region to the low pressure region. At the same time, heat energy is always flows from the high temperature region to the low temperature region. Here, likewise, here charges are also flows from the positive charges are always flows from the high potential region to the low potential region. So means when certain potential difference is exist in between the ends of the conductor, then those charges are in the motion. Yes. So here likewise, here those charges, positive charges, those are always flows from the high potential region to the high potential point or maybe high potential region to the low potential region. High potential region to the low potential region. So in that situation, those charges are in the motion. Here we discussed the positive charges. What about the negative charges? Negative charges are flows from the low potential region to the high potential region. So the flow of the charge we are calling the current or electric current, strength of electric current. Okay, yes. So here we are discussing that current. What is current? Or maybe this is also called as the strength of the electric current. Okay, if you take this one is the electric current. What is electric current or strength of the electric current? First of all, electric current is denoted with the letter I. Electric current is denoted with the letter I. How we define that electric current? How we define that electric current? So that electric current is defined as the rate of flow of the charge. The rate of flow of the charge. So rate of flow of the charge through any cross section of the conductor. Rate of flow of the charge is how we define that? The rate of flow of charge through any cross section of the conductor is called electric current. Try to observe this statement. Yes, try to observe the statement. The rate of flow of the charge through any cross section of the conductor is called electric current. Try to observe here. I am taking this is the one conductor. Here something, this is the cross section. Something A is the area of the cross section of the conductor. So across this cross sectional area, capital Q is the charge passing through this cross sectional area in the time interval of t seconds. Then current is said to be I is equal to Q by T. The rate of flow of the charge is called as current. The rate of flow of the charge through any cross section of the conductor is called electric current. So here, therefore, I is equal to Q by T. Or maybe currents are not the steady one. So in case in t time, Q is the charge crossing through this cross sectional area, and in the time interval of t plus delta t, in the situation charge passes through that cross sectional area is Q plus delta Q. In that situation, we are writing current I is equal to limit delta t tends to 0. That is nothing but delta Q by delta T is equal to, this is the dQ by dt. We are calling that is nothing but the instantaneous current. That is called as the instantaneous current. So here whatever it may be, either instantaneous or maybe current I is equal to Q by T, or maybe that is equal to dQ by dt. So here dQ by dt means that is the instantaneous current. dQ by dt means instantaneous current. So current I is equal to Q by T, or maybe that is equal to dQ by dt. What about the units for the current? Here units for the current, units for the charge. Charge is measured in coulombs. Per time is measured in seconds. Coulomb per second, that is we are calling the ampere. That is called as ampere. Means 1 ampere is equal to 1 coulomb per 1 second. 1 ampere is equal to 1 coulomb per 1 second. How we define this ampere? Okay, we will define that one also. Here one more thing, here current is the scalar physical quantity. Current is a scalar physical quantity. Actually observe, this one consists of some magnitude. At the same time, when we switch on, current is passing from the starting position, switch to the fan, or maybe switch to the light, any electrical device. So we mentioned the direction also, but this one is not the vector physical quantity. That is a scalar physical quantity. Why current is scalar physical quantity? That one consists both magnitude and direction, but that is the scalar physical quantity. Why? Because this one does not obey the laws of the vector addition. vector addition. Laws of the vector addition. Does not obeys the laws of the vector addition. That's why current is a scalar physical quantity. Yes, I will give you some detailed explanation further. Yes, here I am taking, this is the one conductor and second one, this is the third wire. Okay, not conductor, wire. Okay, conductors only. Here I1 is the current, that is equal to something 4 amperes, and I2 is equal to 3 amperes. 3 amperes. Okay, here both are perpendicular to each other. I am giving you that angle is equal to something 90 degrees. In case if that one obeys the laws of the vector addition, resultant current I is equal to square root of I1 square plus I2 square plus 2I1 I2 into cos theta, according to the parallelogram law of the vector addition. According to the parallelogram law of the vector addition. Here I mean theta is equal to 90 means the current I is equal to square root of I1 square plus I2 square. So that is I is equal to square root of 4 square plus 3 square, that is equal to square root of 25. Current I is equal to 5 amperes. But practically, so here current passing through this conductor, that is the third conductor, is 7 amperes. Means here that one just obeys the ordinary algebra, not the vector algebra. So current is a scalar physical quantity. Why? Because that one does not obeys the laws of the vector addition. That one does not obeys the laws of the vector addition. Okay? Right. Here current direction means, what is the direction of the current? Actually that one consists direction also. Here what is the direction of the current? Means that is nothing but the direction of the flow of the positive charges. In case, try to observe, this is the conductor. Here positive charges are moving in this direction. This is the direction of the current, or maybe conventional current direction. That is nothing but the direction of the current is opposite to the direction of flow of the negative charges, means electrons. Electrons are moving in this direction. Current, this is the direction of the current. That is the direction of the current. So right now we will define the ampere. How we define that ampere? Yes. How we define that ampere? So observe here, 1 ampere is equal to 1 coulomb per 1 second. 1 coulomb per 1 second. So from this one, how we define this ampere? Ampere is defined as, if 1 coulomb of the charge, crosses the, that is the passing through the conductor through a cross-sectional area in 1 second. In 1 second. That is we are defined as, that is we are defined as 1 ampere. 1 ampere. Yes. Once again, so how we define the ampere? How we define the ampere? If 1 coulomb of the charge passing through the cross section, passes through the cross section of the conductor in unit time. In unit time, that is nothing but the 1 second time. So 1 ampere is equal to 1 coulomb per 1 second. In 1 second time, how much of the charges crosses are passing through that cross section of the conductor? That is nothing but the 1 coulomb. So then the current is said to be 1 ampere. Current is said to be 1 ampere. So next one, we know the current. Current I is equal to, yes, current I is equal to, that is the Q by T, that is equal to dQ by dt, instantaneous current. Instantaneous current. If small n number of the charges, electrons, if small n number of the electrons passes through that cross section of the conductor, then current is equal to how much? Current I is equal to, yes, observe, we know that charge is quantized. Charge is quantized. Charge of the any body is always integral multiples of the charge of the electron. So here some charge n is the number of the electrons crossing that passing through the cross section of the conductor, then Q is equal to Ne. So here I is equal to, that is nothing but the Ne by T. So here this is in terms of the number of the electrons. I is equal to NE by T. Here E means that is the charge of the electron. That is the charge of the electron. In terms of the number of the electrons. In terms of the number of the electrons. In case, if current is the variable one, if current is the variable, then how we find out how much of the charge is passing through that? How much of the charge is passing through that conductor? Yes, try to observe here. So I is, that is the function of time. Current is the function of time. Variable currents. Current is the function of time. That is equal to, here that is nothing but the dq by dt, instantaneous current. I is equal to dq by dt. From this one we want to find out the charge passing through that conductor in the given interval of the time is equal to how much? In the given interval of the time. That is the dq is equal to I of t into dt. So we want to find out the just q is equal to how much? Integrating this equation, integral of dq is equal to integral of I of t dt within the limits from t1 to t2. Something first 1 to 2 seconds, 1 to 3 seconds, 1 to 5 seconds, or maybe 2 to 4 seconds, 2 to 6 seconds. How much is the charge passing through that conductor? So integral of dq is equal to, integral of dq means that is nothing but dq. Q is equal to integral of t1 to t2 I of t into dt. I of t into dt. So charge is equal to, charge q is equal to integral of t1 to t2 I of t into dt. I of t into dt. We will solve one problem based on that. Yes, observe here. Current is the one problem. Question number 1. Current I is the variable that is equal to something 3t square plus 2t plus 1. 2t plus 1. Find the current, find the charge passing through the conductor, passes through the conductor in between t is equal to 1 second to t is equal to 3 seconds. How much of the charge is passing through that conductor, given conductor? So means, observe this one, how we solve that. We know that q is equal to integral of t1 to t2, that is the time interval, given time interval, I of t into dt. Here t is the, current is the function of time. Current is the function of time. Therefore q is equal to integral of 1 to 3 seconds, 1 to 3 seconds, I of t into dt. I of t into dt. That is equal to integral of 1 to 1 to 3 seconds. Here this is equal to 3t square plus 2t plus 1 whole into dt. So therefore q is equal to, for that one integration, that is the t cube by 3 plus 2 into t square by 2 plus that is equal to t within the limits from 1 to 3 seconds. 1 to 3 seconds. Therefore current, charge, not current, charge q is equal to 3 cancel, 2 cancel, that one is equal to how much? So 3 cube, 27 minus 1, 27 minus 1, that is equal to 26 plus 9 minus 1, 9 minus 1, that is equal to 8 plus 3 minus 1, 2. So this is equal to 36. 36 coulombs of the charge is passing through that. 36 coulombs of the charge passing through the conductor. So in case of the variable currents, what is the charge passing through that conductor? This is the equation. This is the formula. Okay, right. Next one. Yes, next one. In the discharge tube, in the discharge tube, N1 is the positive charges, N1 be the positive charges moving from left to right. N1 is the positive charges moving from left to right. Next, N2 is the negative charges, those are moving from the right to left. So then, what is the total current passing through that discharge tube? What is the total current passing through that discharge tube and in which direction? Observe that one. Here, N1 is the positive charges, means N1 into E, that is the total charge. Total charge passing through the conductor, that is the discharge tube from left to right in the time interval of t seconds. Same thing, N2 negative charges, those are flows from the right to left in the time interval of t seconds. Then what is the total current? Total current I is equal to how much? Total current I is equal to how much? Okay, total current I is equal to, actually current is equal to charge by time. Charge by time. Here two charges, positive and negative, both are passing through that conductor. Means here I am taking I1 is the current path due to the positive charges and I2 is the current due to the negative charges. I1 is the current due to the positive charges and I2 is the current due to the negative charges. First we will find out what is the value of the I1 and I2. Yes, I1 is equal to N1 into E by time t. So what about the direction of the I1 current? Direction of the I1 current. So in the direction of the current direction is along the direction of the motion of the positive charges. So this is the direction of the positive charges. So current direction is also in the same direction. Next one. What about the negative charges? Negative charges are moving in this direction. Negative charges are moving from right to left. So what about the direction of the current due to the negative charges? From the left to the right. So means I1 is also left to the right, I2 is also from the left to the right. So both are in the same direction. Therefore current I is equal to I1 plus I2. What about the I2 value? I2 is equal to N2 into E by T. I is equal to NE by T. So here number of the charges, positive charges are N1, negative charges are N2. So that's why here I1 is equal to N1 into E by T, I2 is equal to N2 into E by T. Therefore current I is equal to N1 into E plus N2 into E whole by T. That is equal to N1 plus N2 by N1 plus N2 whole into E by T. This is the current. This is the current. Its direction is from left to the right. Left to the right. Left to the right. So therefore, in the discharge tube, what is the current? Current I is equal to N1 plus N2 whole by T into E. So depends upon this tube. Here we are taking like this, that is the direction of the current. In case positive charges are moving in this direction, negative charges are moving from left to the right. In that situation, current direction is from right to the left. So from this situation, this is the direction of the current is from left to the right. Left to the right. So next one, if charge is revolves around the try to observe. Yes. Next one, if a point charge if a point charge Q that is revolving in a circle of the radius r meters. Circle of the radius r meters. When this charge is in the motion, compulsory that one according to the definition of the electric current, when charges are in the motion, compulsory that one produces the current. So here, when this charge is moving on the circumference of the circle having the radius r meters, then what is the value of the current generated? So current I is equal to how much? Current I is equal to how much? So try to observe first of all, when that is moving on the circumference of the circle with certain angular velocity omega, so that one completes the one rotation in the time interval of something small t seconds. Okay, total completion, if you take capital T also no problem, that is the time period. So current I is equal to, this is nothing but the charge by time, that time is equal to capital T. I is equal to Q by T, but 1 by T is nothing but the reciprocal of the time period, that is nothing but the frequency. So frequency F into Q. So what is the value of the F, or maybe what is the value of the 1 by T? Try to observe. Time period is equal to, that is nothing but the distance is equal to circumference by velocity, that is nothing but the V, here that is nothing but the V. Time period T is equal to distance by speed. So here from this one, substitute this value, T value here, I is equal to Q by 2 pi R by V. So from this one, I is equal to QV by 2 pi R. So current I is equal to QV by 2 pi R. Here R is the linear velocity. So we know the relation between the linear velocity and angular velocity. V is equal to R omega. Therefore, V by R is equal to omega. V by R, that is nothing but the omega. That is equal to Q omega by 2 pi. So current I is equal to QV by 2 pi R, that is equal to Q omega by 2 pi. This is the value of the current when the point charge is revolving on the circumference of the circle having the radius r meters. In that situation, current is equal to how much? This is the value of the current. Okay, next one we will discuss that is the current density. What is the difference between the current and current density? We will discuss that one in the next video. Okay, bye all of you.